Hey Billy, thanks for taking a moment.
Hey, what's up?
I got a few things actually. Let's start with virtual threads. I read an article from Netflix that there are circumstances where they block an operating system thread. That's terrible for scalability. Haven't we been updating our applications to start using virtual threads?
Yeah, that happened in synchronized blocks. When virtual threads blocked, they were supposed to release their block back to the platform thread, but in synchronized blocks, that didn't happen. But in JDK 24, that fixed it, so our update to JDK 25 should also address that issue.
Whew. Okay, so that's one less thing to worry about.
Yeah, and there's a lot more good stuff in there on performance and runtime in JDK 25 as well. Oh, the camera crew is back again. I gotta go.
What? We have a lot more to discuss.
Oh, hello there, and welcome back to Road to Java 25. I was just talking with Peter there. One of the great features added in JDK 21 was virtual threads. As Peter mentioned, an issue with virtual threads at the time was that they wouldn't release their lock back to the platform thread if they encountered a blocking operation in a synchronized block or method. This issue was recovered in this article from Netflix, which Peter mentioned. The good news, we don't have to worry about this anymore because it was resolved in JDK 24 with JEP 491 synchronized virtual threads without pinning. It's one of the many improvements we receive when upgrading to JDK 25. Let's take a look at all the other performance and runtime goodies we are getting in JDK 25. One of the biggest, though sometimes overlooked reasons to update to the latest JDK is all the performance improvements you get for free. Without even so much as recompiling code, we can see improvements in the startup and throughput performance of the Spring Boot Pet Clinic application. With the application consistently starting in the high 2.4 to mid 2.5 second range when using JDK 25. While usually a bit over 2.6 seconds when using JDK 21. For throughput, I use the OHA toolkit from my latest video for 5 seconds. When running this test code against JDK 21, I would typically complete around 6,500 requests, which would increase to around 8,500 when running the same load again now that the JVM was warm. Performing the above against JDK 25, the results were around 7,500 cold and 10,500 warm. So that comes out to around a 15 to 20% throughput improvement. My testing did show a durable high usage of heap memory when there wasn't a max heap size set in my testing with the Pet Clinic app. The committed heap space would typically be around 400 megabytes on JDK 21 and 480 megabytes on JDK 25. When setting the heap space to 400 megabytes for JDK 25, it had little impact on throughput, and indeed the amount of heap space used was well below the max heap space limit, usually around 240 to 250 megabytes. So it seems some of JDK 25's internal heuristics might be a bit more optimistic with memory usage when given the option, but nothing that won't be too significantly impacted by setting an appropriately sized max heap. As always, performance isn't one thing. It's not just throughput or memory usage. The relative importance of startup, throughput, latency, memory usage, and so on will vary between businesses and applications. And they can be tweaked considerably by which DC you use, max heap size, and many other settings, which we'll talk about a bit later in this video. Also, application architecture plays a very big role because these performance improvements are the result of the compounding changes made between JDK 21 and 25. For example, on Insight.java, one of the JDK engineers, Peter Meinborg, published an article about how strings got even faster in JDK 25. He and another JDK engineer, Klaus Redstadt, also published an article about performance improvements in JDK 24. You can find a number of similar articles for every JDK release on Insight.java. The point is, if your application is doing a lot of work with strings, you'll notice more of a performance improvement from all the collective effort that has gone into improving string performance. If your application is working with native libraries and memory, there were some improvements to the FFM API in JDK 24. All this to say, virtually all applications work with strings. Some work with native libraries. Most applications use the G1 garbage collector, and so on. The extent to which your applications use features that have received performance improvements will impact the amount of performance improvement you will see when updating to JDK 25. I wouldn't anticipate a 15 to 20% throughput increase for all your applications like we're seeing in my simple example, though you should generally expect to see some non-trivial improvement. So this is also what I was seeing in the internal performance testing done on OpenJDK between JDK 21 and 25. These cover a lot more use cases than what I cover in my simple example using the Spring Boot application, and also done in much better isolation than what I did simply on my laptop. And this is also in contrast to the relatively small difference in performance between JDK 17 and 21, which I talk about in this video. And this is all before more active improvements like using an AOT cache, which I talked about in the previous video. One new runtime feature that caught my interest and was delivered as a final feature in JDK 25 is compact object headers. This came out of Project Lilliput, which is focusing on reducing the size of compact object headers on the Hotspot JVM. Which, if you don't know which JVM you're using, it's probably Hotspot or a derivative of it. In short, while analyzing heaps on 64-bit variants of the Hotspot JVM, which would be the only variant available now, a very significant portion of the object's memory allocation was tied up in the header. Many objects are between 256 and 512 bits in size, and 128 bits of that was devoted to the object header, 64 bits for a multi-purpose header, and a 64 bits class pointer. Now, a production feature in JDK 25, compact object headers reduces the size of object headers to 64 bits. This can be enabled with the plus compact object headers command line option. So the performance you will see when using compact object headers will be a bit mixed. As you expect, there is a reduction in heap usage, and a side benefit of that is also a reduction in GC pressure, so less latency. However, overall throughput was lower. This seemed to be a result of how object locks were being handled, though there are other cases of compact object headers causing performance regressions, as noted in this article, though also cases of throughput improvements. So ultimately, using compact object headers will be a bit more situational, requiring testing and an analysis of the relative importance of throughput, memory usage, and latency at your organization and for the applications being evaluated. If you're a user of ZGC, and if you're primarily supporting web applications, I would highly recommend checking ZGC out. A change to ZGC from JDK 21 is now the only mode offered is generational. Generational mode was introduced in JDK 21 but wasn't the default. Between JDK 21 and 25, the ZGC team made rapid work on migrating to generational mode and deprecating and removing single generational mode. Overall, the performance in regard to both CPU and memory usage should be better in nearly all use cases, which is why it has become the only available mode. So it's pretty much a straight upgrade if you have been using single generational mode up to now. We'll take a closer look at ZGC in the next section and why you should consider migrating to it for web applications. So if there's one feature that I'm constantly telling other developers at ACME Soft to use more often, it is the JDK Flight Recorder, which is a diagnostic and observability framework built right into the JDK, which is great. It means we don't have to go out and download some other library or plugin or pay some other vendor. JFR is useful for tracking down performance issues like resource leaks, locking issues, or which parts of an application would provide the most benefit from being refactored. It can also be a great tool for implement bugs, perhaps that occasional long-running query or connection issue that only comes up every 2 or 3 weeks. The best part is JFR only has a minimal impact on performance, so we can run it non-stop in production and have lots of detailed data available for when issues occur. So with JDK 25, JFR got even better with 2 major updates, but before I get to them, let's quickly review how to use JFR. One of the great things about JFR is it's super easy to get started. All you need to do is include start flight recording in your Java command. But you probably don't want to just use all the defaults that JFR uses. To change these, the start flight recording command can take several options. I won't go through all of them, but a few notable ones would be to include file name, which you can use to provide a meaningful name to the recording. Otherwise, the default would be the process ID and timestamp, which might be a bit difficult to deal with in a production setting. Consider also adding %t to your file name, as this will add the timestamp to the recording. Other key options would be max age and max size. Both are default to unlimited. It would be good to set one or both. A max age of 1 day would be a good way to get a rolling snapshot of an application over a day. And if you add the %t to your file name, well, then your recording files will be nicely organized by date. Finally would be settings, which would point to a settings file, just an XML file with a specific schema containing configuration for how events should be captured. This would be helpful when you have created custom events at your organization. We here at ACME Soft had created a number of our own custom events to track transactions, calls to our services, and more. It's a very flexible framework, though I don't have time to cover this feature in depth. Watch this video to get a programmer's perspective on JFR. So, back to the basics of using JFR. For this example though, I will use the options report on exit, a new option added in JDK 25, which will automatically open the created JFR file in a JFR view, in this case the garbage collector view, when the JVM is shut down. It's a great way for quickly evaluating the results of our performance tests like we'll be doing here. So I mentioned how GDC would be a good option for web applications. Let's get a bit of a deeper comparison between G1GC, the default garbage collector, and ZGC. So with this test, I ran the Spring Boot Pet Clinic application with a 500 megabyte heap and used OHA again to generate load. When using G1GC, we processed around 7,500 requests. Looking at the report from JFR, we can see we have around 100 GC pauses, with a number of GC pauses halting the JVM for multiple milliseconds. Let's try this test again with ZGC. Okay, this time we only processed 6,300 requests. That doesn't look great, but throughput isn't GDC's goals. It's focusing on reducing latency. And when we look at the JFR report, we can see that not only does it have fewer GC pauses, these pauses are much shorter, most only being tens of microseconds long. So with ZGC, you trade off some throughput, but in return you get greatly reduced pause times, which can be important in web applications, particularly in a microservices architecture, to ensure users get a snappy response. This is but one example of how JFR can help with doing performance analysis. I also used it when doing analysis comparing JDK 21 to 25 and also comparing performance when using and not using compact object headers. As I mentioned at the start of this section, there are 2 major changes coming to JFR in JDK 25. JEP 518, JFR Cooperative Sampling. This one isn't too interesting to talk about as it's an implementation change to improve JFR stability, but the JEP is definitely an interesting read. What is a bit more interesting is JEP 520, JFR Method Timing and Tracing, which provides events for timing method execution and tracing the call stacks of methods. This can be great for tracing all the ways a method is being used at runtime or timing how long it takes to execute a method. What is nice about this though, this is all done through configuration. You don't have to make any code changes. So the Pet Clinic app uses Spring data. Let's say I want to track the execution time of the data layer. In the start flight recording command, I would add method timing and the fully qualified name of one of the methods in the simple JPA repository, which actually does the work of calling the database. In this case, I will use the dump on exit command, which will automatically create the JFR file on JVM exit, which we will analyze later. Okay, let me do some quick clicking around of the Pet Clinic app. And now I'll shut it down. Using JFR View, which was added in JDK 21, it is what was used automatically with the report on exit feature earlier. I can also configure it to print out a wider table and put that output in a text file. This will make it a little easier to work with. Checking out the results, we can see some basic statistics regarding the execution of find all methods in simple JPA repository. If we wanted to trace the calls to these methods, that can be done somewhat similarly. Instead, we will simply do method trace with the fully qualified method name to simple JPA repository. With JFR View, we will select by the method trace event name, and we will also set a cell height of 20. This dictates how much of the stack is shown in the report. And with that, we can see that the vet controller is the source of these calls to simple JPA repository. But again, one of the great things is to enable these features requires only configuration changes. You can even configure this on an actively running application with JCMD, but that's a conversation for another day. Hopefully this demonstration will make you consider using JFR on your applications. All right, thank you again for joining me on the road to Java 25. We have a few more episodes coming up with Anna covering security and Peter on API changes. So long!